Hello students, now let's have a quick look at what remainder factor theorem is all about. Children, they give us an equation in terms of x is given to you, f of x will be given to you an equation, and we need to find out whether it's a factor, whether something is a factor or not, or what is the remainder. In both cases, children, what we do is the equation that's been given to us, like for example, if you've got 3x cubed minus 7x squared minus 2x plus 9, where the factor is x minus 2, take it equal to 0. So x is equal to 2. When we substitute that in, children, so we get f of 2 is equal to 3 times 2 cubed minus 7 times 2 squared minus 2 times 2 plus 9. That gives us 8 into 3, 24, minus 4 times 28, minus 4 plus 9. That gives us, children, minus 32 plus 33 to give us a remainder of 1. But children, if this were 8 by any chance, then children, if this were 8, then their value would come out to be 0 over here. This was 8 because this would have been 32 minus 32, which is 0. And if it was 0, then x minus 2 would have been a factor. X minus 2 would have been a factor of this expression, children. So now let's apply that. Question says, use remainder theorem to determine which of the expressions x minus 1, x plus 1, x minus 2, x plus 2 are factors of 3x cubed minus 7x squared minus 2x plus 8. Find all the factors of the expression. Find all factors of the expression. So children, function of x has been given to us is equal to 3x cubed minus 7x squared minus 2x plus 8. So now children, x minus 1 equal to 0, x minus 1 equals 0, x is equal to 1. So f of 1, children, would come out to be 3 minus 7 minus 2 plus 8. That's 11 and that's 9. That is not equal to 0. So x minus 1 is not a factor. F of negative 1, children, means this sign will change to negative 3. This will remain negative 7 because negative 1 squared is positive, negative is negative. Plus 2 plus 8. That's 10 and that's 10, which is equal to 0. Therefore, x plus 1 is a factor. Now children, next they've asked us for x minus 2. So f of 2, children, would come out to be 3 times 2, that's 24, minus 7 times 4, that's 28, minus 2 times 2, that's 4, plus 8, that's 32, and negative 32, so that's equal to 0. So again, children, we get x minus 2 is a factor. And then children, they've asked us for f of negative 2. So the first value would come out to be negative 2 cubed, that's negative 8, to negative 24, minus 28, plus 4 plus 8. That's not equal to 0, children. Now children, since we've already got two factors, we might as well just simplify it. We might as well do long division for it, children, to get to the final answer. So we got x minus 2 and that other thing, the quotient divisor. That's 3x squared to give us 3x cubed minus 6x squared. Change signs. minus x squared minus 2x, that's minus x to give us minus x squared plus 2x, change signs, so it will cancel off to give us minus 4x plus 8. It's negative 4 to give us minus 4x plus 8. Change both signs to give us 0. Now children, once we have this, we factorize it. That's 3x squared minus x minus 4, that's negative 12. Factors would come out to be the same, that's negative 4x plus 3x minus 4. That's, take common, x, 3x minus 4 plus 1, 3x minus 4. That's x plus 1, 3x minus 4. And the other fact, that's x plus 1 we already got, children. This was the other factor that we didn't have. And the original factor that we have, x minus 2, to give us the expression that's 3x cubed minus 7x squared minus 2x plus 8. This is the next question, children. The expression, a very common question, children, that they ask is this with simultaneous equations involved, that the expression 2x cubed plus ax squared plus bx minus 2 leaves a remainder of of 7 and 0 when divided by x minus 3 and x plus 2 respectively. Calculate the values of a and b and hence factorize it completely. Hence factorize the expression completely. A sum like this, children, would be for 5 marks. First, we take the expression, write down the expression that f of x is equal to 2x cubed plus ax squared plus bx minus 2. F of x plus 2 equal to 0. F of negative 2, children, we substitute in place of x, put in negative 2, so that's negative 2 cubed plus a times negative 2 the whole squared plus b times negative 2 minus 2 is equal to 0. So the remainder is 0, children. That also means it's a factor. So that's 0 is equal to 2 times negative 8, that's negative 16 plus 4a minus 2b minus 2. Bring everything on the same side, children. That's negative 18. So to give you 18 over here, divide everything by 2. So that's 9 is equal to 2a minus b. The first expression. Second expression, children, would be 2x minus 3 equal to 0, x is equal to 3 by 2. And the remainder, children, over here is given to us as 7. So that's 2 times 3 by 2 the whole cube plus a times 3 by 2 the whole squared plus b times 3 by 2 minus 2. 7 is equal to 2 times, that's 27 by 8, so 27 by 4 plus 9a by 4 plus 3b by 2 minus 2. Children, multiply everything by 4, so you get 28 is equal to 27 plus 9a plus 6b minus 8. Bring everything on this side, children, so we get 30. 6 is equal to 27 plus 9b plus 6b. Dividing everything by 3, children, we get 12 minus 9 is equal to 3b plus 3a plus 2b. That's 3a plus 2b is equal to 3. That's 3a plus 2b is equal to 3. Now multiply the first equation by 2 children, we get 18 is equal to 4a minus 2b. Cancel this out to give us 7a is equal to 21, a is equal to 3. And once you get the value of a is 3 children, we can sub that in the first equation or second equation. That's 9 is equal to 2a minus b. A is 3, so that gives us b value is equal to 2 into a, that's 6, minus 9, that's negative 3. So children, the expression becomes, a function of x becomes 2x cubed plus 3x squared minus 3x minus 2. Once we have this expression, children, we already have a factor. The factor is x plus 2. Since remainder is 0, now we'll do long division, children. That's x plus 2, 2x cubed plus 3x squared minus 3x minus 2. That's 2x cubed divided by x, 2x cubed divided by x, that's 2x squared. So that gives us 2x cubed back here plus 4x squared. Change the signs to give us minus x squared minus 3x. That's negative x to give us negative x squared minus 2x. Change signs. It's negative x minus 2. That's negative 1 to give us negative x minus 2. Change both signs, and that gives us 0 and 0. So now, children, the expression becomes 2x cubed plus 3x squared minus 3x minus 2 is equal to the first factor, that's x plus 2, into the quotient, that's 2x squared minus x minus 1. Product and sum it, children. So we get x plus 2, 2x squared, the product is negative 2. The numbers would be 2x squared minus 2x plus x minus 1. That's x plus 2, 2x, x minus 1 plus 1, x minus 1. That gives us, children, x plus 2, 2x plus 1, x minus 1. These are the three factors. That's why they've asked us to factorize completely, children. Now, let's see next question, children. Given that x minus 1 is a factor of x squared plus mx plus 1, show that x minus m is a factor of x cubed plus 3x squared plus 3x plus 2. Now, children, x minus 1 has been given to us as a factor, children. So we'll take the expression as g of x is equal to x squared plus mx plus 1, where x minus 1 equals to 0, x is equal to 1. So g of 1 would come out to be 1 plus m plus 1 equals 0. M comes out to be negative 2. Then they say, children, x minus m, that becomes x plus 2, is a factor of x cubed plus 3x squared plus 3x plus 2. Show that. So, children, f of negative 2, first f of x is equal to x cubed plus 3x squared plus 3x plus 2. F of negative 2 now, children, comes out to be negative 2 the whole cube plus 3 times negative 2 the whole squared plus 3 times negative 2 plus 2, which simplifies to negative 8 plus 12 minus 6 plus 2. That's negative 14 plus 14, which is equal to 0. Therefore, x plus 2 is a factor. Of x cubed plus 3x squared plus 3x plus 2. That's what they asked us to prove, the children. Prove that x plus 2 is a factor of this expression. We did that, and the remainder is 0 since f of negative 2 equals to 0. With this, children, we end this. Thank you.